Hello everybody. So today I want to show you how to find the radius of convergence. The first thing we need to use about Maclaurin series in here. So that is about cosine t. So in this one we have number 1 minus about t to the power of 2 over 2 factorial in here plus t to the power of 4 over number 4 factorial in here. So in this one we can see that we have cosine t that is in here, but we have negative number 1, so cosine t minus number 1, that means number 1 in here they will eliminate, so we just have only this one. So in this case we can put it to the summation in here, and now in this one because they start at this one, that is the first term, but we eliminate number 1 in here, so they will start at t equals to number 1 and go to infinity. Because this one they will be like this. So because we eliminate number 1, that's why we start at t equals to number 1. Now the next one we divide by t, so we have cosine t minus number 1 we divide by t, so that means this one we have in here. So we need to put t go in here. So t to the power of 2 and divided by t, we can write like this. So we can put this one inside this one. So we have the integration from 0 to s. So we can see that this is about the numbers, so we just do this integration in here. So we have the formula. But we have the bounds, so we don't need about c in here. Now we put 2n minus 1 go in here, so 2n minus 1 plus 1 we have 2n, and we have another 2n in here, so that means we have the summation from t equals to number 1 to infinity. We have negative number 1 to the power of n. This one we have 2n over 2n multiplied by 2n factorial in here, and then we put the bounds from 0 to s. Now we put s and number 0 go in here. So this means we just have only s, because this is about 0, everything inside the 0 you got number 0, so we just have only s. And now about the radius of convergence. So I will use about the ratio test. So I will put an, that is about this one, and an plus 1, that is negative number 1, and plus 1, because if I put n plus 1 go in here, so you got about number 2 multiplied by n plus 1, so 2n plus number 2. Similar for this one. So we have the limit and approach to positive infinity. We have the absolute value of an plus 1 over an. Because I will put this one go in here, and this one go in here. So in this case, if we simplify, we can say that positive or negative, we can cancel this one because this is inside the absolute value. This one divided by this one, so that is about s squared. So this one divided by this one, so this is about factorial. So this one we can put 2n factorial multiplied by 2n plus 1, 2n plus 2. So in this case, this one they cancel, so we just have only 2n plus 2, 2n plus 1, 2n plus 2. So that is like this. And the next one, that is about 2n. Next, I will put limit in here, there is no space. So after we simplify, we can see that we divide by 2n. So 2n they will go in here. So when n approach to positive infinity, this one you got number 0, but we still have number 1. And if this one go to infinity, this one under this one they will go to infinity. S squared divided by infinity, you got number 0. Number 0 is smaller than number 1. That is about convergence. So that means s in here, they can be anything number. So the radius of the convergence, that is infinity. This is the end. Thank you for watching.